Hey, and welcome back to the lab. And today here on the bench I'm already working on an SHF 13 centimeter module which will not transmit in the right way. So the module is out of a Yaesu FT-736, so that is the optional SHF module which you can buy as additional module for your radio. And well, I've completely taken it out of the radio because I needed to have access to it. And first I thought it might not that much interesting to anybody, but now it turns that it could be something what you would like to see, and therefore I thought, come on, let's see what we have and what we are doing. And so here we are, and let's direct go here into our project. Well, and here is our project, and the original problem was that it was not really possible to transmit on 13 centimeters, so we didn't see any output power. And therefore, of course, we have to go through our stages, and finally it gets to the power amplifier stage. And what we have here is finally our power amplifier module, which is a hybrid SHF power amplifier. And now the next step here is to test it against the data sheet to determine, is it really a problem here with our module, or maybe are we on the wrong way. So therefore I've prepared here already the entire setup, and yeah, let's go ahead. And here is what we have. So that is finally our Mitsubishi RF power module. And well, the problem is that it is obsolete, so you cannot really get it new from Mitsubishi Japan. So yeah, you can get them from China, but you never know if those modules are really fine or if they might be at the end fake. So we know that that has happened in the past, because it is always a rebuild which the guys over there are doing, which is fine, because it is from time to time the only way to get for an older radio, you know, a part. And we all know, if we do not have the right part, okay, we could start and do it completely new, but that is on the other hand very time consuming, and that very often does not make real sense. So therefore I always try and see if there is a rebuild, and if so, we give them a try, but we have to be aware on the fact that what we get could be fake. So that is what it is. But on the other hand, I got very often components which were really fine. So, you know, there are some black sheeps over there in China, but you know, it is definitely that most of the guys over there are doing a fine job. So therefore we will give it a go as well. Important here is our, let me enlarge it here a little bit. Okay, that was a bit too much. So we have here our graph which is showing us output power versus input power characteristics. And that means I do not have the right driving power available, but what I have is from my generator I have 100 milliwatt, and that is how we go testing it. So with 100 milliwatt we should be able to see at least 7 watt output power. to understand what we have in the radio, the module is given as 10 watt output power in the Yaesu specs. So if we can test here with 100 milliwatt, which I have from my signal generator, so that means 20 dBm, positive 20 dBm, and that is 100 milliwatt, and we should see approximately 7 watt output with approximately a bit over 3 amps consumed power. And what we see as well, that we have to drive our component here with 12 volt, 12.5 to be precise, and that our VBB have to be 9 volt. We test it on 1.24 gigahertz, and that are the precautions we have to arrange here, and then we can finally say if our module is working or not. And therefore we have to work here with 3 different power supplies. So the one here in the middle is the 12.5 volt, and we expect with 100 milliwatt approximately, let's say, 3.5 amps. So therefore that are the presettings here. Then we have our let us call it bias or TX voltage in general. So that is 9 volt, and we are expecting approximately 450 milliamps where it should run on. And then we see we need here 1.1 volt, and that is a kind of control voltage which have to switch through finally our bias voltage right to our module. Okay, so that is the reason why we need these 3 different voltages. And then here on the other hand we have our power meter, and of course we set it to watt so that we see how many watt our output will be. And as we have discussed it, so we expecting approximately 7 watt to know that the module is working fine. And so we have to monitor this. And on the other hand, we have here our generator, which is finally working on 1.24 gigahertz with, now it is only on -7 because I increase the drive very slowly up to 20 dB, positive 20 dB, which represents finally then 100 milliwatt to drive our unit. Okay, so the first what we are doing is switching in here our 9 volt, and what we see is 77 milliamps. So that is our transmit relay. So that has already switched, but our bias voltage is not yet connected to the module itself. So now I'm switching in here our 12.5 volt, and of course we do not see nothing because now we need first to connect our 1.2 volt. And that is for this little module where we have a little logic on, which will switch the little transistor here through to be able to get our voltage to, finally our PA module. And this logic needs a negative voltage, a negative minus 1.2 volt, and therefore you see that I put here my red to the blue. And now when I switch it in, yeah, you better should see here our power supplies. Because now you see that we have here 448 milliamps, and that is what I've said, what we expect having our bias directly at our power module. And we see that the power module itself with our 12.5 volt started to consume power, but it is far not what we want, because we do not drive the module right now. Therefore we go over here to our power meter, and now I switch in our RF on 1.24 megahertz, and now I start increasing my level. Okay, so now we are already on 0 dBm, and you see we have 9.6 milliwatt, which is almost nothing if we talk about a transmitter. Okay, but we increase it forward, so now we are 7 as a positive. Now we are talking about positive 7, positive 8, 9, 10, and you see it is increasing over there. 11, 12, wow, it is already 141 milliwatt. 13 dBm, 14 dBm, 15 dBm, 16, 17, 18, 19, and now we are on 20. And what we can see is that the module itself is delivering 1 watt output power, and that is far too less. So we would expect with 100 milliwatt input, so that means 20 dBm, we would expect, as we have seen it in our data sheet, 7 watt output power, and we would expect approximately 3.5 amps consumed power. But when I go over here, so you see that the module itself is only consuming 1.1 amps, so that is below under what we expect, and that means we can now say that our power amplifier is toasted. So that means that I really have to take it here apart, and we need to go down that we get access here to our hybrid. And what we have seen here in our block diagram, we see that we have 3 individual power amplifiers, maybe, and yeah, maybe one of this is broken, so that we get finally only 1 watt. And since we cannot repair an individual power amplifier here on the board, yeah, we finally have to swap out the whole hybrid. Okay, and what I have in stock is this here, so that is the hybrid, and you see there is a nice Mitsubishi logo on it, but as I already said, I do not really know if it is an original Mitsubishi. I really doubt it, but anyways, so that is the only way to get finally, yeah, an obsolete component, and therefore let's hope and try, let's cross fingers, and let's see if it finally works. Yeah, and here you have a better view onto our module, and you see here is our transmitter relay, and under this shielding we find our module. So let's go ahead and let's see what we can do. Now all the screws are off, and let's try that we get here our module out. So it is always a little bit sticky because here of the heat compound I believe. So here we have it, and now we really can go ahead and solder it here off from our PCB. And here we have our module off, and what we have to do right now is to clean here the board, and then we go for the new module. Alright, everything is clean, and we really can go ahead. So let's take here our new device, and let's see how it finally works out. So of course we have to cut our leads here a little bit, fit it in, and then let's see if it works. Okay, so our new hybrid module is in, and yeah, let me bring it back here into the housing. Let's prepare it for testing, and then let's see what we get. Okay, back to our SHF module. Well, for you it is just a second ago, but I'm already 4 weeks older or so. So we really had a lot of trouble. So that here is the original module what was in. Okay, and now in our jig here we have the new model which came from China, and let me tell you, that module doesn't work. So that was most likely a fake module. So I got in touch with a supplier in China, and I showed him in a video that it doesn't work, and yeah, all fine, no problem whatsoever, but then you are without a new PA module what you need. So we found another supplier in Italy, and that is the one I have here. So that is a brand new module. So, and we hope that the new one will work, because the problem is here our FT-736R from Mitsubishi is obsolete. So you cannot really get it any longer. So there might be some distributors, they still have the original Mitsubishi component in stock, and we hope so that the one we have here finally received from Italy is now fine. But what we got from China is definitely not an original Mitsubishi one, and that is always a problem with old radios. So a lot of components are definitely obsolete, so you can't buy them, you can't buy those modules, components, transistors, or what have we. You can't buy them any longer, and so it is really a problem. Okay, so what does it mean now? So I have to take off once again the one we have inside here. We take it out and we replace it with a new one. Then we go through the test procedure, and I really hope that the new one will work. So let's go into it. And as you might imagine, it is not really easy to get it apart again. because the shielding here is soldered to the PCB, and you see it is very narrow here to get down to the soldering points. And yeah, so you know, it is really not funny to do this job once again, but well, it doesn't help, because we cannot leave it like it is. And therefore now let's get off here the component, the fake component, and yeah, let's see if we can then fit the new one in. Another hint what I want to give you is that, so that is the one I've taken out, and here everything is now clean, so we can really put the new one in. So when I bought it on the internet page, it was not showing the Mitsubishi sign. And when I received it, Mitsubishi sign was printed on. So what does it mean? I have no clue, but after all, that is not really, you know, you do not really know what you think about it. It all pointed more and more to the fact that someone tries to fake something here. So anyways, just open your eyes when you order obsolete parts where you know that they are really difficult to get on the market. Okay, so new PA is in, so now I have to put it here into the housing, and then we go for testing. Okay, so we are now here in test configuration. So here is our module, everything prepared. So we have here our test head, and we have here absorber, and finally a dummy load. So we know this unit will deliver 10 watt output power in our radio. So with the test configuration we will not completely reach 10 watt, because I can only feed here this configuration with 20 dBm, which is 0.1 watt, and that is much lower what the driver of the radio will deliver. But we want to check if the unit itself will work, because before we saw nothing. So that means now we want to really check if we can see anything. Okay, up here on the generator you see I have set 1.24 gigahertz, so that is a test frequency, and I will increase it up to 20 dBm, which is, as I said, 0.1 watt. And with that driver power we should reach approximately 4 watt in our configuration. So let's see how it works out. And of course down here at our tester we have set it to watt, so therefore we can monitor the output power of our amplifier, right, and see if the module delivers power when I'm increasing our input signal from the generator. And remember, maximum input level I can deliver with my generator is 20 dBm. I mean, that is much for a generator, but it is not enough to drive fully our module here. So let's see what happens. And of course, first of all, we need to connect our voltages. So here on the right hand side, 9 volt, so that is our bias voltage, and it is also driving our TX relay, right? Then 12.5, so that is the main power for the amplifier. And then I have here another 1.2 volt, so that is a little switching circuit which is needed to finally switch our 9 volt to the bias circuit. So that is additional little circuitry which has Yaesu built in here in this unit. So that means we start to supply our unit here in the test setup with our 9 volt bias, and you see with 9 volt bias we are drawing now 74 milliamps. So that is not enough, so therefore I have to activate here this little circuit, and now you see bias comes up to 450 milliwatt, and that means our bias circuit seems to work entirely right now. And now I have to supply finally the main voltage for the power amplifier, and you see it is running with 360 milliamps, but there is no drive, so there is no signal at the input, and the fake module only was drawing 50 milliamps, so nothing really happens. So that is already really a good sign. And also here our bias current is absolutely fine, so that looks perfect. So that makes me really hoping. Now I have to feed our input power, and once again here is our input, so that is coming from the generator. Okay, and then now let's observe finally here our power meter, and as I said, it is set to watt. And now let me switch in my generator, so we are at -5 dBm, and you already see we have 11 milliwatt output. Now let me increase it, and you see it is coming up, so that is very good. So that is 2 dBm already. So let me go further, and you see 0.5 watt. And now 1 watt output power, 2 watt out, 3.6, so that is approximately 4. Now we have 20 dBm input power, and we have 3.6 output power from our module, only with 20 dBm. The radio will deliver, I believe, 32 or 33 dBm, which then will finally deliver enough input to give us 10 watt output power, as it is specified here with our radio. So that really looks perfect. And look over here. So now we are reflection. So now we are drawing 2.3 amps on the main power, and that looks promising as well. So now I have to switch it off because it is really getting too hot. So let me take it off. But anyways, that means that obviously our unit is working, and that means I can really put everything back together, and we can install it back into the radio, and then cross fingers that everything is fine, and we really can get 10 watt output power out of our radio on SHF. Again, we are at 1.24 gigahertz, so that is SHF, and well, very promising up to this point here. Let's go ahead. So finally I have aligned here our filter transformers to get to the maximum output, so that we have the right setting according our manual, and that, you know, the final is working just fine. Let me demonstrate that at our ALC alignment point. So let's see if we have everything in view. And now when I am pressing here PTT, you see it is putting out 11 watt, and you can see that I can really take it up to, yeah, much too much. So I take it down around to 10 watt, because really you should not over drive this unit. I mean, this unit is somewhat sensitive first for high temperature, so it is now already, you really can feel it, and especially here the driver stage, so that is really hot. And secondly, this power amplifier is really sensitive against high SWR, so you always should know that your antenna setting is fine. So really go down to the lowest output power to check your antenna on the needed frequency. But never put a radio, or this radio, especially with this power amplifier, do not put it directly to an unknown antenna. So that can definitely kill your final stage here. And you have seen the trouble we had to get a new one. So there are a lot of fake power amplifiers on the market, so be careful. It is getting always more critical and more complicated to get an original one which is working, definitely. And here what we can say, and I really have to show it because I like it. This is where we got it. So you see the original Mitsubishi code, and you see that is RF Microwave, and that is a company in Italy which is really delivering working stuff. Thank you to this company. Okay, I'm finishing now here the alignment. So I put the radio to 11.5 watt output power, because with increasing temperature, our output signal, or our output level decreases a little bit. So therefore I put it to 11.5 watt, and then it is definitely fine. Okay, and you can see what I'm doing here. So yeah, okay, we put it something into this area, so that is definitely fine. 11.6, so that is perfect. Alright, and after we've done now the power output alignment, we had to check here our frequency. And you know, when we are working on 1280 megahertz, it is really critical to have and crucial to have the master oscillator running correctly. So our master crystal or oscillator here is running on 20.4 megahertz, okay, and this is now supplying the reference frequency for our 1280 megahertz. All right, so you see how much the frequency get cranked up to get to the wanted frequency, and therefore it is absolutely crucial to get it as close as possible. Okay, and I really had to do it off camera, so you all know how touchy those alignments are. But have a look. So I now press our PTT, and it is jumping to takes. And what we see here is we are really only, and you see it is already moving a little bit, and you see it is perfect. So we are within, let's say, 3-4 hertz where it is moving up and down. So that is really nice and the best what we can do. And of course I've here more you see now you can read here the 1280, but the resolution is reduced, so therefore I'm going up here, so we are losing one digit here on the left hand side, but therefore we have more digits here. And you see it is moving within, yeah, let's say 3-4 hertz, and that is absolutely perfect on that high frequency. And you see how closely it is matching here the dialed in frequency, so that really means everything is absolutely fine and is working perfectly. So I do not touch our reference oscillator any longer, so that is fine, and everything else is fine as well. And the last test here on 1280 will be our receive, and let's go over to our tester. Okay, so what you see here is that we have a really good synod, and our signal is crisp and clean, so everything absolutely fine. I'm feeding -93, which is a nice S9 level here on the higher frequencies. What you see here now is -121 dBm, which is quite low without preamplifier, by the way. And you see, so we are still reaching our 12 dB, sometimes a little bit more, because of course the signal is noisy, so we can hear it a little bit. That is normal, all right, but it is important that we see we are able to reach our 12 dB even with that low input level. So that means our receiver is fine as well. So I really can't show and tell you more. So everything else has been tested before: 70 centimeter, 2 meter, 50 megahertz, so that means 4 meter, and of course the rest of the unit. Maybe there is here and there a switch which is not working perfect, but don't forget, this is really an old radio, and you have seen how difficult it finally was to get all the parts we need. So that is the reason why it becomes more and more difficult to get those old radios back working. But I'm quite happy with this result now, and I hope that the owner will have another couple of years some fun with the radio here. Okay, so we are finally at the end of the video with a nice and lucky outcome, and that's it for today. Thanks for watching, and catch you next time. Bye.